Hello everyone, let's solve this question. So this is also module instantiation based question as given here. So in this question we have two inputs which is having 32-bit length. Okay, and we have two adders and each one can add 16 bit. So what we can do here, LSB side 16 bit means 15 down 0, we can pass through this adder, first adder, and remaining 31 down 16 bit we can pass through this second adder. Then after that both some output we will pass through this sum which is having 32-bit length. Okay, so here see C in for this first adder is 0. We need to take this 0 because they have given like that only. And C out we need to ignore because there is a no port for this C out and they mention in this question. We need to ignore this C out. Okay, and one more thing, the carry of this first adder is going, C out of this first adder is going as a C in for this second adder. So here this pin is acting as a wire because this is the output for this first adder and input for this second adder. So we need to declare one wire. Okay, so in this way we can add this 32-bit two numbers by using two 16-bit adders. Let's write the code for this question. First we need to declare wire W. Next, see, this is the add 16 module has given here, module add 16, and here first they mention input 16-bit input, then input A, then input B, then input C in, then output that is 16-bit sum, then C out. Okay, so in this way we can write. So I will instantiate that module add 16, write some U1. Next, I am using by positioning method, so I can write like A 15 down 0, B 15 down 0. Next is C in, but here in this first adder C in is 0, so I can write 1 tick B 0. Next sum, output is sum, so output of this adder is going in the LSB side of this 32-bit sum. Okay, so here this sum is going in the 15 down 0 sum, so we can write like that, sum 15 down 0. Next C out, so C out of this adder we declare as a wire wire W, so we can write here W. So this is the code for this first adder. Okay, now we need to instantiate this second adder. So add 16 U2. Next A, so here in the first adder we pass 15 down 0 bit, in remaining bit we are passing through this second adder. So what are the remaining bits? 31 down 16. So here we can write like that, 31 down 16. Next B 31 down 16. Next C in, so here C in is coming from this C out, so what is that? C out is W. Okay, we declare this one as a wire, so we can write W in place of C in, we can write W. Next sum, in here sum is going through this 31 down 16 sum. Okay, 31 down 16, and here C out, so in place of C out we can write 0. As they mention in the question, we can assign 0 or we can ignore that. Okay, so this is the code for this question. Let's check it. Okay, so whatever we wrote, that is correct. Okay, so in this way we can solve this instantiation based question. Let's solve one more question. So this question is also same, but here see, here also two 16-bit adders are given, and they have given how this 16-bit adder is doing its functionality with the help of full adders. So in this 16-bit adder, there are total 16 full adders given. Okay, and see, this is the full adder. In this full adder, one bit A, one bit B is going here, C in, and one bit sum and one bit C out is going out. Okay, so sum is directly going through this sum 15 down 0, and after that here. Okay, but C out is passing through each full adder. Here first full adder C out is going as a C in for the second one, and then it follow same. Okay, so this is the internal we can say working of this add 16-bit full adder. Okay, or add 16 module. So in this question we need to write only two modules, that one top module and this module. Add one means this one module, add one module. Okay, so in this add one module we need to write the functionality of this full adder, because this add one module is the full adder. Okay, so we need to declare those things, and these two add 16 we need to just instantiate whatever there inside in this add 16. We don't care about that. Okay, we need to just write the code for this top module and add one module, and we need to instantiate these two modules add 16. Okay, and we don't care about this inside, whatever the inside bit in this add 16 we don't care. Okay, so those things they mention in this para, just read it out. Okay, so I will just write this code here. See, we will first write the code for this full adder, means this module, add one module. Okay, so here this is the module, two inputs A, B and C in one input, so total three inputs. Okay, and sum and C out, these two are the outputs. So here what we can write, assign sum equal to A XOR B XOR C in. This is the expression for this sum in the full adder. Next, assign C out equal to A and B or B and C in or A and C in. Okay, this is the expression for this C out in this full adder. So this module we wrote. Okay, next what we need to do, we need to instantiate these two modules as we solved in the last question. In the same way we need to write this thing. Okay, so here add 16, next A 15 down 0 comma B 15 down 0 comma, here input is 0. See, this is the add 16 module they have given. So in this way we need to write first input A, B and C in, then output sum and C out. So in the same way we need to write. So A, B we wrote, and here C in is 0. Okay, so C in is 0. Next sum 15 down 0 comma here see in the last question also we discussed these things. So here see out it is going as an input for the second one, so we need to declare here wire. So I will declare here an wire w. Okay, so here we can write w because this is the cout for this first adder. Cout, in place of cout we can write here w. Okay, next add 16. So here we miss instance name, I will write u1. Next here instance name is u2. Here a 31 down 16, b 31 down 16. Next here c in is w. Okay, w. Next sum 31 down 16. In cout we can ignore, so I will just write 0 in place of cout. Okay, so this is the code. Okay, see here we wrote only add one module, and what is inside in this add 16 that they mention in this question they mention. So don't write what is the inside in this add 16. That's why we just ignore those things. Okay, and we just instantiate these two modules. Okay, so let's check it. Okay, so whatever we wrote that is correct. Okay, so this is the instantiation based questions. We will solve few more questions in the upcoming videos. Till that, thank you.